My dear student friends, welcome back to GATE Instrumentation Engineering discussions. Okay, so let's see some problems today. So here we have to find out the transfer function between the input and output. Okay, so input is R of S, output is C of S. So R of S and C of S, the gains here and all 1. So gain is 1. First, we know using signal flow graph, using Mason's gain formula, using Mason's gain formula, right? So what is he suggested? The transfer function equal to 1 by delta sigma pk del k, where delta is having some formula. So we already discussed the brief formula for delta, and pk is the number of forward path, del k is the gain. Okay, it is also nothing but delta except the forward path which is not touching. Okay, the gain. So first let us find a solution, right? Let us find the number of forward paths. So we have to find first is number of forward paths. So first solution. Okay. So first step is we have to find number of forward paths. So what is forward path? The forward path is nothing but starts from one point, end at the final stage. So starts from R of S and end at C of S. How many forward paths available in this signal flow graph? Okay, so there are let us calculate one by one number of forward paths. Say from this point you can have one forward path this. Okay, so first forward path. So let P1 is the first forward path. What is P1? G2, G4. It moves from this way. G2, G4, G6, and ends at C. So G2, G4, G6. What is P2? Second forward path. You can have G3 this way. From here or this way, G3, G5, G7. G3, G5, G7. Okay. What is next third forward path? G1. You can have G1, G2, G7. Okay. G1, G2, G7. G1 from starting from here, G1, okay, G1, G2, G7. So this way. So G1, sorry, G2, G1, G7. So P3 is G2, G1, G7, right? What is P4? Similarly, similar to that, you can have this side. G3, G8, G6, G8. Okay, G3, G3, G8, G6. Okay, so starts here and end at here. What is any possible forward path next? So what is P5? You can have G1 this way. Starting from R, G3, G8, H1, G1, G7, end at this one, right? H1, right? So minus. So P5 is minus G1, G2, G2, G1, say G2, G1, G3, okay. Either way you can take. Okay. Second one is, that is fifth one is, what is fifth one? Tell me. Amida solunga. G3, G8, G3, G8. From here, start, it passes through this path, minus of H1. So H1, so minus here, H1, G1, G7. What is next forward path? P6, similar to that, G3, G1, right. So G2, here also minus G2, G2, oh, sorry. G2, G1, first is G3, G8, H1, G1, G7, G3. Now G2, G4, G2, G2, G1, H2, minus H2, then G8, G6, G8, G6, right? So if you order, let us write this, there are 6 forward path. You can write the 6 forward path in the ascending order. That is, there are 6 forward path. So K equal to 6. Okay. So we have to find V6. Okay. That is P1, P2, P3, etc. So up to P6. Similarly, we have to find del K. So del 6. So del 1, del 2, etc. del 6. Okay. So let us rewrite the forward paths. So P1 equal to G2, G6, G2, G6, G4, G6, G2, G4, G6. P2 equal to G3, G5, G7, right? Yeah, tell my ear, what is P3? G1, G2, G7. Then P4, what is P4? G3, this P4, G3, G6, G8. Okay, G3, G6, G8. What is P5? Minus G1, G3, G7, G8, H1. What is P6? Minus G1, G2, G6, G8, H2. Okay. So how many number of individual loops? So how many number of individual loops? So how many number of individual loops? Let's see. Loop means this starting from one end and end at the same point. So we can have G4 minus of L1 is minus of G4 H1. So the L1 loops, individual loops. Okay, these are all forward paths. forward paths. L1 equal to minus G4 H1. See, this is one loop. Similarly, you can have another loop here. So G5 H2 minus G5 H2. So L2 equal to minus G5 H2. Okay. Is any other loop is possible here? So you consider this juncture. So we can move towards this portion. So starting this from G8 minus H1, G1 minus H2. So G1 you can have minus into minus plus. So G1 G8 H1 H2. Loop 3 equal to G1 G8 H1 H2. 2 minus cancel together, so it becomes plus. So there are 3 individual loops. Say next we have to find. We found 3 loops, individual loops. One, this is loop 1. This is loop 2. This is loop 3. Loop 3. So next we have to find how many non-touching loops. Gain product of 2 non-touching loops. So gain product of 2 non-touching loops. Non-touching loops. So what are the 2 non-touching loops? Among these 3, L1 and L2 are 2 non-touching loops. So the L12 is non-touching loops. So what are the 2 non-touching loops? Get product of 2 non-touching loops. Okay. So what are the non-touching loops? G4, G5, H1, H2, L1, L2. Okay. So G4, G5, H1, H2. This is the gain product of 2 non-touching loops. Okay. First combination, only 2 combination. So both L1 and L2, 2 loops are touching with the third loops. Okay. Third loops. So we can't say the one more 2 non-touching loops. So when we go for 3 gain product of 3 non-touching loops, that is also impossible here. Okay. So what we have now, we can easily calculate the gain expression, gain formula. So what is the delta value? So what is delta expression? Delta equal to 1 minus sum of individual loops. Sum of individual loop gains. Sum of individual loop gains plus gain product of, okay, sum of gain product of non-touching loops. 2 non-touching loops. Sum of gain product of 2 non-touching loops. 2 non-touching loops. In this case, only one pair of non-touching loop. So you can have only just L12. Okay. Here's what are the sum of individual loops? L1 plus L2 plus L3. Okay, understand or not? So delta and so on minus, it is impossible in this case. Okay. So what is delta? Delta equal to 1 minus, what is the sum of individual loops? Minus G4H1 minus G4H1 minus G5H2 minus G5H2 G1 G8, okay, plus G1 G8 H1 H2 plus The gain product of two non-touching loops is G4, G5. So G4, G5, H1, H2. G4, G5, H1, H2. Am I right? Are you getting? Yes. Very good. Tell, right? So if you remove the bracket, 1 plus 1 plus G4 H1, 1 plus G4 H1 plus G5 H2 minus, okay, minus of G1 G8, G1 G8 H1 H2 plus G4 G5 H1 H2. This is the required expression for delta. Let us find what is now, according to the expression, we have to find 6 deltas. 6 deltas. What is delta 1? So delta 1 is nothing but the delta, same formula, delta 1 minus sum of individual loops, loop gains, which is not touching the first forward path. So what is the first forward path? G2, let us see, very simple to find, right? Say G2, G4, G6. See, this path is the first forward path. G2, G4, G6 is the first forward path. In the forward path, which gain is not touching, okay, which is not touching the first forward path, which there are 3 loops, L1, this is L2, L3. So which loop is not touching the first forward path, this forward path? This is L2. What is L2? L2 is G5 H2. So that loop gains we have to find, minus G5 H2. So this loop L2 is not touching the first forward path. Plus the possibility is 0. So that is the remaining thing 0. So del 1 is 1 plus G5 H2. Similarly, what is delta 2? 1 minus of the sum of individual loop gains, which is not touching the second forward path. So which is the second forward path? G3, G5, G7. G3, G5, G7. So in this forward path, which is not touching, this loop L1 is not touching. So the loop gain L1, what is L1? L1 is G4 minus G4 H1. So minus G4 H1 plus remaining thing 0. So delta 2 is 1 plus G4 H1. Understand? Any doubt? Tell me. Okay. Next is delta 3. So delta 3. What is delta 3? Same as that of delta. Same as that of this delta. Okay. The same delta here, right? The same delta, except the individual loops which is not touching the third forward path. So what is the third forward path? G1. So third forward path is G1, G2, G7. G1, G2, so G1, G2, G7. Okay, G2, G1, G7. So this is the third forward path. So this both all the 3 loops L1, L2 and L3. All the 3 loops are touching with this forward path. So the sum of individual loops which is not touching the third forward path is 0. So anything 0. So what is that? Delta 3, 1. Similarly, delta 4. Delta 4 is not as that of delta. The 1 minus this delta 4 is 1 minus sum of individual loop gains which is not touching the fourth forward path. So impossibility. So no one loop is not touching the fourth forward path. So all are touching. Okay. So delta 4 also 1 minus 0. So 1. So similarly delta 5, delta 6 all are equal to 1. Right. So we know delta 1, delta 2, delta 3, delta 4, delta 5, delta 6. Then similarly P1, P2, P3, P4, P6 we have. So all the required components, elements are available. So what is our delta? Okay. So what is our delta? So the transfer function equal to 1 by delta. That is, we can write like this: P1 del 1 plus P2 del 2 plus P3 del 3 plus P4 del 4 plus P5 del 5 plus P6 del 6, whole thing divided by delta. Okay, whole thing divided by delta. So what is that? So P1 is what is P1? G2, G4, G6. G2, G4, G6. G2, G4, G6 into the first loop is, what is the first loop? 1 plus delta 1. What is delta 1? Delta 1 is 1 plus G5H2. 1 plus G5H2 plus, what is P2? G3, G5, G7. G3, G5, G7 of 1 plus G4, H1 plus, what is P3? Tell me, dear students, what is P3? P3 is G1, G2, G7. G1, G2, G7. What is del 3? Del 3 is 1. Del 3 is 1. See here, del 3 equal to 1. Del 3, del 4 all are 1. So into 1 plus, what is P4? P4 is G3, G6, G8. So G3, G6, G8 into 1 plus, what is P5? P5 is minus G3, G7 minus G1, G3, G7 minus G1, G3, G7, G8, H1 minus G1 into 1. Okay, into 1. Del 5. G1, G2, G6, G8. Okay, H2 into del 6 is 1. Whole thing divided by. So what is whole thing divided by delta? 1 plus G4H1 plus G5H2 minus G1, G8, H1, H2 plus G4, G5, H1, H2. Okay. So this is the required transfer function. Understand or not? So this is very simple procedure. So next question is, Next question is, okay, so the block diagram of a Facebook feedback control system given below. Okay, so from this block diagram, obtain the following transfer functions. What are the transfer functions? C of S divided by R of S. So first C of S divided by R of S being n equal to 0. If we put n equal to 0, what is the put n equal to 0, what happened? This addition, this loop is cancelled. So this loop will be cancelled. So what is the transfer function? Being n equal to 0. Similarly, C of S by n of S. See, between C of S and n of S, keeping R of S is 0. So what will be that? When this 0, so everything, this value is 0 up to this 0. Clear? So let us see one by one. So similarly, you have to find E of S by R of S. Where is E of S? E of S by R of S. Keeping, this is E of S by R of S. Keeping N of S is 0. E of S by R of S. Also, we have to find the controller with the transfer function gain is for the reduction of effect of noise N, and find G of S so that the output C of S is totally independent of N of S. So what is the solution? Let us see solution. Okay, solution to the problem. Understand? So solution. Okay. So in the first case, n is 0. So while keeping n equal to 0, first case 1, when n equal to 0, what is the number of for loops? Totally, there are totally 3 loops. Okay, totally 3 loops. Understand? So in the first case, how many forward paths? So when this is 0, how many forward paths? This path is not present. So one from R to C of S, one forward path, only one forward path. Clear? So the number of forward path. Understand? So the number of forward path equal to 1. That is from R of S to C of S. Understand? By applying Mason's gain formula. So what is Mason's gain formula? Transfer function between C of S to R of S equal to P1 del 1 divided by delta. So only one forward path. So P1 del 1 alone is sufficient to find. So what is P1? Forward path gain. So first find P1. What is P1? Forward path gain. You see, so in the first forward path, 100 multiplied by S plus 1 by 2 into 10 by S into S plus 2. You have to multiply these 3 gains, forward gains. So that is our result, right? 10 into 100 is 1000. 1000 to S plus 1 divided by S into S plus 2, S plus 20. So P1 is, what is P1? P1 is 100 by 100 into S plus 1 divided by S plus 2 into 10 divided by S into S plus 20. S into S plus 20. Understand? So which is nothing but 1000 into S plus 1 divided by S into S plus 2 S plus 20. This is P1. What is del 1? So delta. What is delta? 1 minus number of individual loop gains. How many loop gains are there? Okay, 1 plus sum of individual loop gains. So see here. So when this is cancelled, so how many loop gains this forward? Oh, okay, this is one, then goes to this. So this is one individual loop. So L1 is S plus 1 by S plus 2 into 10 into S plus 1 by S plus 2 divided by S into S plus 2. Another loop is from here it goes up to this and come back here. So this is another for again individual gain loop. So 100 into S plus 2 divided by this. The third loop is, so loop 1 is S 10 into S plus 1 divided by S into S plus 2 S plus 20. Am I right or wrong? Similarly, what is L2? L2 is, what is L2? L2 is 100 into this loop. From starting from here, it goes up to this and come back here and reaches here. So this loop is, this is minus up, right? This loop is minus up because this is minus, right? So minus. So what is that? L2 is 100 into S plus 1 by S plus 2. Similarly, what is L3? So L3 is this loop from 100 S plus 1 by S plus 2 into this. This is loop 2. 100 into this divided by this entire thing is 1000. Okay. So 1000 into 1000 into S plus 1 divided by S into S plus 2 S plus 20. Am I right? So just place it here. 1 minus what is individual loops? So L1 plus L2 plus L3 plus plus 0. So remaining thing is 0. So what is delta 1? Which is not touching the first word part. All the paths are touching. All the individual loops are touching. So there is no possibility. So delta 1 is 1. So what is the transfer function? So transfer function is, what is the transfer function? So the transfer function is C of S by R of S equal to P1 delta 1. What is P1? 1000 into S plus 1 divided by S into S plus 2 S plus 20. Am I right? S plus 20. Clear? Any doubt? Right. S plus 20. Divided by into delta 1. What is delta 1? 1. So divided by delta. What is delta? 1 plus, okay, L1, L2, L3. If you simplify that, you put and simplify that, you will be getting, say, I will put, okay. So 1 plus 10 into S plus 1 divided by S into S plus 2 S plus 20 plus 100 S plus 1 divided by S plus 22 plus 1000 into S plus 1. Jayashree, tell me. So what is the solution for this? Please calculate and tell me. Very good. S plus 20. So if you take LCM and put the cancel, so you will be getting C of S by R of S equal to 1000 into S plus 1 in the numerator. Denominator is cancelled. So the 101 S cube plus 2122 S square plus 3050 S plus 1010. Okay. So this is the solution for first part. Then what is next question? When C of S by N of S are equal to 0. So C of S by N of S when R equal to 0. So case 2. Let's see what is case 2. Case 2 condition is C of S by N of S by when R of S equal to 0. So what happened? So in this case, there are, say, go back here. So this is 0. So R of S is 0. So what happened? So this becomes 0. So input is 0. So this is 0 minus of this. Minus of minuses this, right? So there are only two forward paths. So from N, starting from N, okay, from N to, so from N to C of S, okay, only two forward paths. This is one forward path, that is M1. So another forward path is this one from here goes here and goes to reach the C of S. So one path and another path. So P1 equal to 1. P1 equal to 1. So from this point to this point, the gain is 1. So P1 equal to 1. What is P2? G of S. Okay, G of S. This is say G of S into this equal to this. This is P. So P2 is this forward path. So according to this, so there are two forward paths. So what are they? P1 equal to 1, P2 equal to G4, sorry, G of S into 10 into S plus 1 by S into S plus 2, S plus 20. Okay. So this is two forward paths. So transfer function equal to, what is transfer function? P1 del 1 plus P2 del 2. Only two delta values, then delta. Okay. So what is according to Mason's gain formula by applying P1 is 1, P2 is this one. What is delta or delta? So what is delta? Delta is nothing but 1 plus sum of how many individual loops? So here there are three individual loops, right? 3 individual loops. So the 3 individual loops are again these 3 are the 3 individual loops. So first individual loop is L1, this one, L2 is again this one, and the L3 is this. Because R of S allowed 0. So all the 3 loops are here. So delta 1 plus L1 plus L2 plus L3. So this is delta. So delta 1 equal to delta 1 equal to 1, delta 2 equal to so delta 1, the first forward path is this one. So which loop is not touching the first forward path? 100 this into this loop. Okay, L2 is not touching the first forward path. L2. So L2 is not touching the first forward path. Okay. Similarly, this loop. Okay, this loop is that. So then second forward path is from this to this. So which is not touching the second forward path? Second forward path 10 into s plus 1, this loop, right? So this loop G4 100 into right. So delta 2 is G4 M2 is that is your second forward path. So the transfer function delta 1 is 1 plus 1 minus half minus 100 s plus 1 divided by s plus 2. Right? 1 of 1 plus. That is M1 is 1. This is delta 1. So what is delta 2? So delta 2 equal to second forward path is G4, this one into this divided by what is that? You see in the when n from n from here from n this is the second forward path. So starting here G4 very good. My dear students, you found the solution. See, very simple, right? So delta 2 is 1. Okay, delta 2 is 1. So what is the transfer function? So C of S by N of S equal to P1. P1 is 1. So 1 into 1 plus 100 into S plus 1 divided by S plus 2 plus what is P2? P2 is G4. See, this is P2. G4 10 S plus 1 divided by S into S plus 2 S plus 20. Right? Very good. Understand? So plus delta. What is delta? 1 plus del L1 plus L2 plus L3. So same as that of the previous. So the final expression for CFS to N of S equal to 101. Please simplify. Konstriji, simplify, please. Plus 2122 S square plus S into 2040 plus 10 G of S. Sorry, this is G of S, not G4. G of S. Okay, G of S. G of S plus 10 G of S divided by 101 S cube plus 2122 S square plus 3050 S plus 1010. So this is the solution for case 2. So what is the case 3? When case 3, then case 3 is case 3. So we have to find the E of S, E of S to R of S. So keeping N of S 0, 0. What is that? Clear? So please try to find the solution, my dear students. Please find the solution. So how many forward paths here? So what is the how many when E of S to R of S? When E of S to R of S, how many forward path? So starting from this, only one forward path, E of S to R of S. So only one forward path. So this one and so only one forward path. Clear? So that forward path gain is also 1. So then what is the delta 1? What is delta? Please do it. So in this case, number of forward path P1 equal to 1. What is the P1 gain? Gain is also 1. So what is delta? Delta equal to, okay. What is delta? Delta is same as that of the previous case. Same. 1 plus sum of individual loops. L1 plus L2 plus L3. So that is the same as the previous case. So what is delta 1? So which loop is not touching the forward path? Okay, what are the gain product of two non-touching loops? 1 minus, only we have two non-touching loops, which is 10 into S plus 1 by S plus 2. Okay, so this loop, these two loops are, you see, this loop, only this loop. So from this point to this point. So only this loop is not touching the forward path. Clear? So L2 is, so 1 plus 1 minus of L the loop gain which is not touching the forward path. So loop gain which is not touching the first P1, which is not touching the P1. What is P1? E to R to E, right? So which is nothing but our L, okay, L2, okay, L1, okay, L1, good, L1. So L1, what is L1? 10 into S plus 1 into S plus 2, right? So L1 is not touching the first forward. So delta 1 equal to L1. So L1. So that is 1 plus 10 into S plus 1 divided by S into S plus 2, S plus 20. So what is the transfer function? So we will be getting E of S to R of S equal to P1, 1, del 1 is this one. So into 1 plus 10 S plus 1 divided by S into S plus 2, S plus 20, right? S plus 20. Whole thing divided by delta. So what is delta? 1 plus 10 L1. S1 divided by S into S plus 2, S plus 20 plus 100 into S plus 1 divided by S plus 2 plus 1000 into S plus 1 divided by S into S plus 2, S plus 20. So this is delta. So what is the final answer? Please simplify, my dear students. Please simplify and tell me the answer. So E of S by R of S equal to, so if we simplify this, Kunshnidhi, please tell me the answer. Amida, Where are you? S cube plus 22s square plus 50s plus 10 divided by 101 s cube plus 2122 s square plus 3050 s clear plus 1010. Understand? So this is the answer for part 3. What about part 4? That is number of, in this case, what we have to find? See, the controller with, you see, the controller with the transfer function g of s is for the reduction of effect of noise n. So we have to find g of s so that the output c of s is totally independent of n of s. So how to find this thing? So y of s by n of s, we have to follow the second case, c of s by n of s. Understand? C of s by n of s, we have to consider that. So case 2. So in case 2, what is how many forward paths? There are 2 forward paths. Clear? So that should be equal to 0. The effect of n of s equal to 0. So the case 4, we have to find g of s, okay, so that n of s, c of s by n of s should be equal to 0. Clear? So what we found, c of s by n of s, c of s by n of s equal to, what is that? Tell me. 101 s cube. Amida, tell the answer. 101. So c of s by n of s equal to, what is the transfer function? 101 s cube plus 2122 s square plus s into 2040 plus 10 g of s plus 10 g of s. This divided by the denominator, that is 101 s cube plus 2122 s square plus 3050 s plus 10. This should be equal to 0, right? So by equating, if we equate this equal to 0, so the denominator is equal to 0. If n of s is 0, so this equal to 0. So what we are getting? So we are getting 101 s cube plus 2122 s square plus, say this is 0. If you cross multiply this, this becomes this 0. So this is equal to s square s into 2040 plus 10 g of s. Clear? 10 g of s plus 10 g of s equal to 0. So what is g of s? You simplify this expression, you will be getting minus 101 s cube plus 2122 s square plus 2040 divided by 10 into s plus 1. So this is the required transfer function for the condition. So with this, any doubt? So please simplify and get this relation. My dear students, any doubt? The next one is using Mason's gain formula. Okay, using Mason's gain formula, find the transfer function between C of S by R of S. Understand? Very simple. We have to apply the Mason gain formula for the loop, right? So let's see what happened. say 1, 2, 3, 4, 5, 6, 7. Okay. So G1, there are G2, G3, G1, G2. Okay. G1, G2, say G3 between G2 across G2. So you can have like this G3, G4, G5 across this G5. Then this gain is G6. So here gain is 1. Here gain is 7. G7. Okay. From here across this can have a feedback. Let us have a feedback of H1. Okay, H1. So G1, this is R of S, or this is C. So another feedback is across here. This is H2. Then third feedback is across this point and H3. So we have to find C of S by R of S. C of S by R of S. So how to solve this? Change solution. Okay, solution. See, first we have to find the number of forward paths. So how many forward paths? See here, from starting point to ending point, we have to find the forward path. G1, G2, G4, G6, G7. This is one forward path. So what is P1? So P1 is G1, G2, G4, G6, G7. Am I right? Next is P2. P2 equal to G1, G3, G4, G6. G1, G3, see second forward path G1, G3, G6, G4, G3, G4, G6, G7. What is P3? Say you can have G1, G2, G5, G1, G2, G1, G2, G5, G5, G6, G6, G7. What is P4? G1, G2, G1, G2, G1, G2, G5, G6. Okay. First forward path G1, G3, G4, G6. Then G1, G2, G5, G6, G7. Okay. Let's have G1, G3, G5, G1, G3, G5, G6, G7. Am I right? So four forward paths. So what is number of loops? There are 6 loops. So L1, L2, This is L3. Sorry. This is one loop L1. This is loop L2. So first loop from here G2, G2, G4. Okay. First loop is L1 equal to G6, G6 H1, L2 G7 H2, L3 is can have G2, G4, G6, G7 H3, L4 equal to G3, G4, G6, G7, H3, G3. Okay, good. Then what is the L? This is L4. What is L5? So starting from this node, okay, this node can have G3 starting from this point, G3, G4, G6, G7, then H3. Then from here, if you start here, G4, G4, G6, G7, H3, G3. Then G2 can have G2, right? So next L4, L6. L6 is, what is L6? Can start from this point. So G6, G7, H3, then G3, G5, G3, G5. So G6, G7, H3, G3, G5, G3, G5. Understand or not? So G3, G5, then H3. So there are 6 loops. How many non-touching loops? Only one non-touching loop, that is this loop. So this loop is not touching with the number of non-touching loops. So this loop and these two loops are not touching, right? So number of non-touching loop is 1. So P1, what is transfer function? Transfer function equal to P1 del 1 plus P2 del 2 plus P3 del 3 plus P4 del 4 divided by delta. Okay. So what is delta? Delta is nothing but 1 minus sum of individual loops. How many individual loops are there? 6 individual loops, right? So sum of gain product of 6 individual loops. Okay, just add P1, L1, L2, L3, L1 plus L2 plus L3 plus L4 plus L5 plus L6. So plus possible combination of any two non-touching loops. Okay, any two non-touching loop is available, only one loop is. So only one loop is available, that is G6, G7. Okay, G6, G7, H3. So what is the final answer? Delta 1 is which loop is only one loop is not touching. So 1 minus the non-touching loops. Okay, so only one non-touching loop. Uh, that loop we have to put here. So finally, what we get? So C of S by R of S equal to. So please take it as assignment. So please do it. This is an assignment. C of S by R of S, you will be getting G1, G6, G7, G2 plus G3, then G4 plus G5, right? Divided by delta 1 minus of G6, G7, H3, G2 plus G3, G4 plus G5 minus G6, H1 minus G7, H2 plus G7, G6, H1, H2. Please do it. Right. This is the answer for the solution. Clear? So next is obtain the Mason's gain formula using by using the Mason's gain formula for this. Okay. Okay. Come back. So we have to apply, right, the Mason's gain formula for this. So first we draw the signal flow graph for this block diagram. So how many forward path is there? So first nodes, junctions we can have. This one junction, another junction, 3, 4, 1, 2, 3, 4, 5, 6. Okay. So this is starting node. So this is the ending node. Clear? So first we draw the gain formula, right? Mason's gain diagram. So starting from solution. Clear? From R of S, 1, 2, 3, 4, 5, 6. Okay, so R of S, this finally C of S. So how many forward path gain is there? So one first one is this is one gain 1. This is the junction. This is another junction. So from the junction, another junction is there. So this is G1. This is G2, G3. Okay, G3. So this is C of S. So between these two, across G1, G2, G3, one forward path is there. G1, G2, G3, one forward path, right? Then from G1, from this junction, one. So this is one feedback. Okay, this is one feedback minus H2 from G2 to this junction. Okay, from G2 to one more feedback, that is minus H1. This is G4. See here. So G2, G1, G2, G3. From G2 out, from the G2 go goes to H1 to the junction. So junction before G2, G4 starts and then add with the block. Clear? So this is addition. Okay, this is addition. This one, this. Finally, between this and this, there is a feedback path. So this is -1, negative feedback, overall feedback system. Clear? So now let us find the number of forward paths. How many forward paths? How many forward paths starting from RS? This is straight forward path. So P1 equal to G1, G2, G3. What is another possible forward path? From G4, that's all. Okay. Okay. G4, that's all. So only two forward paths. So what is the transfer function? Transfer function required for this block diagram signal flow graph representation is P1 del 1 plus P2 del 2 divided by delta. So what is delta? We have to, for calculating delta, we need the number of loops. How many loops are available here? The number of loops. Okay, what is L1? Loop 1 can have this as a one loop. So minus G1, G2, H1. What is L2? Can have another loop from G2, G3 into minus H2. So minus G2, G3, H2. Am I right? All right. So what is L3? Minus G1, G2, G3. Then that's all. So this is third loop. You can have this as a third loop. So any other loop is available? One loop. Okay, G2, G3 minus H3. Okay. From G1, this junction, G4 minus H1. Okay, L4 equal to minus G4 H1. L5. What is L5? L5, please find out, my dear students. What is another possible loop? What is another possible loop? L1 minus G1, G2, H1, right? L2 minus G2, G3, H2. L3 is minus G1, G2, G3. L4 is G4, G4, H1. That is H1 is, sorry, 1. That is minus G4. L5 equal to G2, G4, G2, G1, G2, G3, G2, G4, H1, H2. Say G2. Say this is the last loop. So G2, G2, G4, H1, G2, right? G2, H1, G4. Okay. G2, right? So the last one is G2, starting from here, G2, H1 minus H1, then G4, okay, come back to then GH2 into, it is joining here, understand? So, starting from here, G2, H1, G2, G4, H1, H2. So, there are 5 individual loops. So, which, not, how many non-touching loops? There is no non-touching loop. So, non-touching loop is not exist. Non-touching loops, loops are not available. Are not available in this system, right? So we can easily say that what is delta 1 minus sum of individual loop gains L1, L2, L3, L4 plus L5. There are totally 5 loops plus the non-touching loops. There is no non-touching loops available, so 0. So delta equal to 1 plus G1, G2, H1 plus G2, G3, H2 plus, sorry, minus G4, H2, G2, H1 plus G1, G2, G3 plus G4. So what is transfer function? Transfer function between C of S by R of S equal to P1 del 1. What is P1? P1 is G1, G2, G3. So del 1 is, what is del 1? There is no non-touching loops. Okay, which is not touching the first forward path. Clear? So, del 1 and del 2 both are 1. There is no, all the loops are touching the first, second forward path. First and second forward path. So P1, G1, G2, G3 into 1 plus G4 into 1 divided by 1 plus of G1, G2, H1 plus G2, G3, H2 minus G4, H2, G2, H1 plus G1 plus G1, G2, G3 plus G4. That's all. This is the required transfer function for this system. Okay, clear? So another problem is we have to find the transfer function for this signal flow graph. This signal flow graph. So solution. What is the solution? So what do you have to find? We have to find number of forward paths. Number of forward paths. How many number of forward paths in this structure? So from starting from this to this, how many forward paths? Okay, let us tell the first forward path. We will find P1 equal to G1, G2, the straight route. So G1, G2. What is the second forward path? Second forward path is this one. So just G4. What is third forward path? Third forward path G7, G8. So this will be our third forward path. G7, G8. What is the fourth forward path? G1, G6, or G1, G5, G8. So G1, G5, G8. So this route G1, G5, G8. What is P5? G1, G6 or G2, G7. Okay, let's have this route G7, G6, G7, G8, G2, right? G2, G6. Okay. Is it possible? Okay. So this is downward. So from this point, from starting from here, G7, G6, G2, this one. This is the path 5. Okay. So G2, G6, G7. So there are 5 forward paths. So how many loops? So the number of loops. The number of loops equal to 3. So what is L1? L1 is G3. This is one loop. L1. What is L2? G5, G6. This is one loop. So going this way. Okay, G5, G6. What is L3? G9. So this is L3. So how many non-touching loops? Let us find. See, there are 3 loops. So how many possible non-touching loops? So this loop and this loop are not touching. So L1 and L3. So the 2 non-touching loops. Non-touching loops. What are they? L1, L3 equal to G3, G9. Okay. This is the 2 non-touching loops, L1 and L3. So now, what is delta? Delta equal to 1 minus sum of individual loops, L1 plus L2 plus L3 plus gain product of 2 non-touching loops, that is L1 and L3. So delta equal to 1 minus half G3 plus G5, G6 plus G9 plus G3, G9. So delta equal to 1. That is, this is our required delta. Clear? What is delta 1? 1 minus of same delta, which is not touching the first forward path. So which is the first forward path? This is the first forward path. So which loop is not touching the first forward path? That is L3. So that is the individual loop. So L3 is not touching the first forward path. So 1 minus G9. So second, delta 2. This is delta 1. So 1 minus half. Which loop is not touching the second forward path? So second forward path is G4. So this is the second forward path, G4. Which loop is not touching G4? That is this loop and this loop. All the 3 loops are not touching the second forward path. Okay. So L1 plus L2 plus L3. All the 3 are not touching the first. How many non-touching loops which is not touching the second forward path? That same L1 and L3, right? L1 and L3. So delta 2 equal to 1 minus half G3, G5, G6 plus G9 plus G3, G9. What is delta 3? So which is third forward path? G7, G8. So G7, G8. So in this path, so this loop is touching. Okay, in this path. This loop is also touching. Which loop is not touching? L1. So L1 is G3. G3 alone not touching. So 1 minus G3. This is not touching the. So what is delta 4? Delta 4 1 minus. What is delta 4? Delta 4 is G1, G5, G8. G1, G5, G8. So in this way, all the forward loops are touching. Okay, so 1 minus of 0. So 1. Similarly, del 5 is also not possible, 1. So what is the transfer function? Transfer function equal to P1 del 1 plus P2 del 2 plus P3 del 3 plus P4 del 4 plus P5 del 5. So substitute all the values, my dear students. Substitute the values divided by delta. Please, we substitute and bring it to this form. So if you have any doubt, ask me. G1, G2 into 1 minus G9 plus what is P? G1, G2 is P1. What is L1? L1 is, sorry, del 1 is 1 minus G9. So substitute the values. Then G4, P2 into 1 minus G3 minus G5, G6 minus G9 plus G3, sorry, plus G3, G9 plus G7, G8 of 1 minus G3 remaining plus delta 1 values G2, G8 plus G6, G7, G2 whole thing divided by 1 minus of G3, G5, G6 plus, okay, minus, right, minus G9 plus G3, G9. So please, my dear students, my dear friends, find out this answer. This is the required transfer function. Clear? So with this, we come to the discussion, some solutions on the first chapter. Next, we start time domain analysis. Okay, time domain analysis in the next class. Thank you very much.